Now we are on lesson 3. In this lesson we will discover what is doing each layer separately in OSI model. But do you remember the OSI model? I think most of you yes, but we need to repeat briefly what we learned before. So OSI model is a 7-layer concept which describes how data flows from sending computer to receiving one. Let's repeat: physical, data link, network, transport, session, presentation and application. Each layers communicate with the same layer, with the same level layer in another, in remote computer, in receiving computer. So application layer can communicate only with an application layer at remote side. It cannot communicate neither the session layer, neither physical, network, transport and other layers. Understand? Okay. Now, do you remember how data flow through the network from host A to host B? Of course, data flowing down to the physical layer at sending end, and at the receiving side it's flowing up from physical layer, from the first layer to the 7th layer, to the application one. Yeah, each layer adding its own header and sending this bigger packet to the next layer. And that's how the communication happens. This we call encapsulation and de-encapsulation. Of course, at the sending side we call encapsulation because we encapsulate data into the bigger packet. Where sending, we are putting the data into the box, and at the receiving side, at the host B, we are de-encapsulating the packet. We are putting off the data from the box. Okay, it's very important. Let's continue. Okay, we understand the OSI model, which does not define any protocols and which is only a reference model and no obligations for any protocols, any networking. It's just a model. But in real life we need to simplify all this process, because 7 steps for networking for each packet is too long way. So Department of Defense and Internet Engineering Task Force developed a simpler 4-layer model called TCPIP model. TCP stands for Transmission Control Protocol and IP stands for Internet Protocol. So this is much more simpler, much more easy to understand than OSI reference model. So any group of protocols in different layers in which our communication happens we call protocol stack. Now we will discuss about TCPIP model, or simply TCPIP stack. Of course, TCP and IP are only 2 of 1,000 protocols that can be used in this model, but we call it TCPIP. It's a name only. So let's compare 2 of these models. At the left hand, we can see OSI reference model, which consists of 7 layers. Let's remember: physical, data link, network, transport, session, presentation, and application layers. On the right hand, we have TCPIP model, which consists of 4 layers: network access, internet, transport, and application layers. So of course, TCPIP model should work through OSI reference model. It means, in other words, it means that in each layer of TCP/IP model, one or more than one layers of OSI reference model can be combined. Let's see. Here in application layer, the 3 upper layers are combined. They are application, presentation, and session layers. In a TCP/IP model, they are stands for application layer. Next, the transport layer remain the same. Both the name is the same, unchanged, and it stands for the 4th layer in OSI reference model. Next one, it's a network layer. As we can see, the 3rd layer at the left hand is located network layer. On the right hand side, network layer is renamed and its name is internet layer. Again, is the TCP/IP reference model. So, the next final one is the network access, which is a combination of physical and data link layers of OSI reference model. So, as we can see, we have simplified the 7-layer OSI reference model into 4-layer simple TCP/IP model. In practice, however, most of people describes TCP/IP model using 5 layers. In OSI reference model, the first 3 layers we combined in 1 layer in TCP/IP model. The same thing in 5-layer model. Upper 3 layers of OSI reference model we combine into the same application layer. Transport layer, both in OSI reference model and TCP/IP model remains the same, so it is in 5-layer model. Network in layer in TCP/IP model renames to internet layer. In 5-layer model, we remain the same as it is in OSI reference model. It's a network layer. Next was the real difference. In TCP/IP model, we combined 2 layers, physical and data link layers, into 1 network access layer. In 5-layer model, we remain the same, the data link and physical layers as there was in OSI reference model. So this is the common model of networking reference. So in future we will describe this model, 5-layer model. Now let's have a look how data flows through the network using 5-layer model. When a computer sends an information, a data, to another remote computer, at first the data processing by the application layer. It means that application which is processing the data, it could be, for example, Skype or Outlook or Internet Explorer or something else, is processing your data, adding some headers and giving to transport layer. But before giving to transport layer, it defines which kind of software application is used. It gives to transport layer. Transport layer proceed the data and giving it to the network layer, then to the data link layer, then to the physical layer. After it, the electrical signals is transmitting through the medium, and the receiving computer side is receiving the same electrical signal. So physical layer gives all the data to the data link layer, which is processing and removing the header. After it, data flows to network layer. It's a layer 3. It removes its header, its own header, and giving to transport layer, which is removing also its header, which contains which type of protocols will be used, which ports. It's not a computer port, it's another port, and giving it to application layer. Let's discuss application layer. Application layer protocols specify details such as how data should be encoded, compressed, or encrypted, and how sessions should be managed. Application layer has its own protocols, such as HTTP, which stands for Hypertext Transfer Protocol, SMTP, which stands for Simple Mail Transfer Protocol, SNMP, which stands for Simple Network Management Protocol, FTP, File Transfer Protocol, and so on. In 5-layer model, application layer could be proceed by the following programs. You can see Chrome, you can see Internet Explorer, Outlook Express, and so on. After that application layer proceed the information, it gives to the transport layer. Transport layer specifies which application layer protocol should be used to proceed the data on the receiving computer. Each application layer protocol is assigned a unique numerical identifier called a port, which is used to identify the protocol. Again and again, do not mix this port with a computer port, with a computer LAN port. It's another port. It's an application port. For example, HTTP, as you remember, stands for Hypertext Transfer Protocol, has a port number which is standard, and its number is 80. DNS, which stands for Domain Name Service, so its port number is 53. So transport layer adds a source port number, destination port number to the data, which includes also the application layer header, and transfer it. The port numbering you can see, you can discuss, you can learn in using the RFC 1700 or going to this link. Here all the ports which are standardized are referenced. There are two major protocols used by transport layer, which are TCP, which stands for Transmission Control Protocol, and UDP, which stands for User Datagram Protocol. There are different protocols by its concept, by the speed, by the processing capacity, and so on. Transmission Control Protocol, or TCP, relies on sending data and receiving the confirmation of them. Just imagine you are sending a data and waiting until the receiver will send you a response, will send you a confirmation that he received the information. This will make you sure that your data will receive correctly, but you will have low speed and high latency. UDP is another type of protocol. It just sends the information. No confirmation required for this protocol. And you can send the information, and even the packets will lost, you will not be able to know about this. UDP protocol is used for voice over IP services, for example, Skype, video transmitting, video streaming services, TV streaming services. But TCP protocol used in such kind of FTP, file transfer protocols, where you need to exact the data to be transmitted. Let's go to next layer. Network layer. Network layer identifies the upper layer transport layer protocol that is being used. Each transport layer protocol is assigned a unique identifier or IP protocol number. UDP stands for 17 and TCP stands for 6. Also, network layer. Add the source IP address and destination IP address as a header. So overall we have 5 headers to the data. Layer 3. So what can we say for layer 3? You maybe saw the routers. If no, you can go to the server room in your university and ask the administrator to show you a router. It could be like this, or like this. These are 3 different vendors' routers which are found for you. Another layer, data link layer. The data link layer receives packets and adds its own header to each packet to create a frame. The header usually includes another address, referred to as a layer 2 address, or a physical address, or a MAC address. So adding to overall the packet destination and source addresses, physical of course addresses, we will get 7 headers added to data. But data link layer also adds a checksum at the end of the data and sends to physical layer, which is sending it through the medium. But don't hurry, just look at the another pictures. These are layer 2 switches and LAN cards or network interface cards examples. You can see, you can compare which one is yours. Physical layer. Physical layer converts bits into electrical signals and sends them across the physical medium, which can be a telephone wire, a fiber optic cable, or even a wireless environment. All these specifications are defined by physical layer. Even the connector type, even the voltages, all these are defined by physical address. So network equipment type, impedances, connector types, it could be RG45, it's for copper twisted pair, SC, LC, FC for optical wires, BNC for coaxial cables, and so on. Pinout cross, it could be TIA, EIA, 568A or B, or other things. It's a cross connection. We'll talk you later about this. So medium, it could be fiber optic, copper, or air. So this is the end of lesson 3.